Hey everybody, welcome back to another lesson. I hope you all had a good weekend, and before I get started, I just wanted to thank everybody for the hard work they've been doing and everything they've been getting done. Been really happy with what I've seen so far from the people who've been doing work. They've been doing really good. I also want to encourage you to keep on communicating with me and Mrs. Stofflet, and I'm really happy with the communication I've had the last week. A lot of people have been asking really good questions, and even if you want to just contact us to just tell us how you're doing, it doesn't have to be a question necessarily. Just let us know how you're doing with everything, how you feel about what you're learning. Even if you feel like you're doing really good, you feel like you really understand it, don't be afraid to just let us know. We really like getting those emails and just getting ideas of where everybody's at with the new lessons that we're teaching right now. All right, so today is the last lesson of the chapter, and that does mean there will be an assessment on Wednesday, but I will post a bunch of review materials on Tuesday, none of which will be mandatory for you to do, but they will be good ideas just to get some ideas and practice with some of the material that will be on the assessment. So, before I get started, now we can get started. All right, so we're going to be doing dilations in the coordinate plane. And I feel like this will be a little bit easier than the last lesson, because the last lesson was pretty hard, and this one isn't too bad from my opinion. So it is dependent on the individual person, so it might be harder for some and less hard for others, but I think it'll become a little bit easier. So a dilation with a scale factor of k will be an enlargement of an image. So all we're doing is enlarging the image, and it has to be larger than the original if k is greater than 1. So if our scale factor is greater than 1, our image will get bigger. If it's getting smaller, our k will be from 0 to 1. It'll be less than 1, but greater than 0. Your k will never be negative. So it'll be the same as the original figure if k is 1. Because if you multiply anything by 1, it is itself. So that sounds a little complicated, but it'll make a little bit more sense when we start going into our examples. And I want to test something real quick. Yeah. So the pre-image and the image are the same shape, but not necessarily the same size, since the figure is enlarged or reduced by a scale factor. So they will be the same shape, but they will not be congruent, because the size can be different lengths. They will have the same scale factor, they will look like the same shape, but one will be bigger or smaller, depending on what k is. It could also be the exact same, but it doesn't have to be, is what the point of that is. Alright, so let's try an example, and then it'll make a little bit more sense after we go through this example, I believe. A triangle has vertices A, 0, 0, B, 8, 0, and C, 3, negative 2. Find the coordinates of the triangle after a dilation with a scale factor of 4. So that means our k value is 4. So if we go back up to where our symbols were, right up here, k times x and k times y is our new point. So what they did, the dilation is xy, so they multiplied 4 times every x and y value. So for their a value, their vertex was 0, 0. They multiplied x and y by their scale factor of 4, which is still 0, 0. For b, 8, 0 was their point, so they multiplied each x and y value by their scale factor, which is 4. So 8 times 4 is 32. 4 times 0 is 0. C, their c values were x was 3, y was negative 2. They multiplied that by a scale factor of 4. X of 3, 3 times 4 is 12. 4 times negative 2 is negative 8. So all we do with dilations is multiply every number by our scale factor, and that gives us our new points. So the coordinates of the dilation are a prime 0, 0, b prime 32, 0, and c prime 12, negative 8. So our new points are 0, 0, our new b is 32, 0, and our new c is 12, negative 8. Another reminder, you can always go back through it, and just in case you didn't quite get it the first time. There's also the tutor buttons and the watch buttons for other teachings on this. So let's try a got it. Remember, scale factor, you need your scale factor of 2 and you need your coordinates. Those are the things you need for these types of problems. So your coordinates and your scale factor. Let's see if I can highlight this. All right, so try that one on your own, and then when you feel like you've got it all figured out, resume the video, and I'll go through it with you. So pause it right now, and then I'll go through it. All right, now let's try this. So my W value was -2, 4. My X value was 1, 4. My Y value was 3, -1. And my Z value was -3, -1. So for each of these, my scale factor is 2. I have to multiply the X values and the Y values by 2. So for W, I'm going to start doing multiplication by 2. So I have -2 times 2, 4 times 2. And that'll give us our new W prime, which is -4, and 2 times 2 is -4, and 8. Kind of ran out of room there. So -4 and 8. 2 times 4 is 8. So we're just multiplying for these. My X value, I have a 1 and 4. So 1 times my scale factor of 2, and 4 times my scale factor of 2. So this lesson's mainly multiplying. There is a little bit of division later on, but let's focus on this for now. So my new X value is going to be 2. 4 times 2 is 8. Now, for my Y value, I had 3, -1, so I'm doing 3 times my scale factor of 2, and -1 times my scale factor of 2. So my new Y value is 6. 3 times 2 is 6. -1 times 2 is -2. So that's my new Y value. And keep in mind, you have to really pay attention to the negatives, because I can see that messing some people up. So make sure you're keeping track of what's negative and what's not. So -3 times my scale factor of 2, and -1 times my scale factor of 2. And that gives me Z, my new Z is -6, -2. And that is my new dilation. So my new points are all these points over here. So hopefully yours match up. If not, look to see where you made a mistake and try to correct it. All right, so our next example. A figure has vertices, try to focus that. A figure has vertices J at 3, 8, K at 10, 6, and L at 8, 2. Graph the figure of the image after a dilation with a scale factor of 1/2. So our scale factor is 1/2. This means that our K is less than 1 and greater than 0, so it's going to be a reduction. It's going to get smaller. So keep that in mind. So the first thing you have to do is graph your original points, which they did. So they did 1, 2, 3, and they went up 8 to this point, and they went over 10 and up 6 to this point, and L was over 8 up 2. So they graphed their first image. Now they multiplied everything by 1/2. So they're 3 times 1/2 and 8 times 1/2. And they got their new J, which is 3/2 and 4. And they graphed that over 3/2, so 1.5, and up 4. 1, 2, 3, 4. There's their new J. Same thing with K, multiplied by 1/2 by both of their points, both their X and Y, and they got 5, 3. 5, 3, 1, 2, 3, 4, 5, up 3. 1, 2, 3. This is still just multiplication. We're just adding the process of graphing it into this example. For L, they had 8, 2, multiply both by 1/2, and they get 4, 1. 1, 2, 3, 4, 1. Now, to check their answers, they said that you could draw lines through the origin in each of the vertices of the original figure. The vertices should lie on those same lines. So what they're saying is for your new k and your old k, if you draw a line through them, that line should go through the origin. This is just a way to check your answers. You don't have to. This is just a check on your answers. So with J and their new J, they drew a line through those two, and it does go through the origin, so it's correct. They drew a line through these two Ks, and it does go through the origin. Those are correct. Both L's, the new L and the old L, they drew a line through them. It goes through the origin. It's correct. So it has to go through the origin and the 2 points that correspond to each other. So L, new L and L, those two. So we're going to try another got it. Try it on your own. And then after you pause the video here, come back when you figured it out, or think you got it figured out, and we'll go through it together. So let's start with just graphing. My F is -1. So -1 and 1 is my Y value. So we go up 1. So that is F. My G is 1, 1. So over 1 for X and up 1 for my Y. H is 2, -1. So over 2 for my X and down 1 for -1. And I is -1, -1. So left 1 for -1 and down 1 for -1. So we have a nice little quadrilateral. And we can draw our lines in to mark that. All right. So now let's look. That we have our points, and now we find our scale factor. So figure of after a dilation with a scale factor of 3. So scale factor of 3. We need to know that. So we're taking each of these points, -1 and 1. That's my F. And we're going to multiply this by my scale factor. So I have -1 times 3 and 1 times 3. So my new F, F prime, is -3, 3. And I kind of ran out of room. Sorry about that. But it's all right. I think you can read that. So G is 1, 1. And I'm going to be multiplying this by my scale factor of 3. So I have 1 times 3 and 1 times 3. Both of them times 3. That gives me my new G, which is 3, 3. H, same thing. 2, -1. Multiply both of those by my scale factor of 3. So 2 times 3 and -1 times 3 gives me my new H, which is 6, -3. And lastly, I have I, which is -1, -1. Multiply both of those by my scale factor of 3. So -1 times 3 and -1 times 3. So my new I is -3, -3. Now, all we have left to do is graphing all of these. So, I didn't label all my points. Let's label all my points first. So G, H, and I. I like to keep track of where my stuff is. So, F prime, -3, 1, 2, 3, 1, 2, 3. -3, 3. So my new F is up here. My new G is 3, 3. So 1, 2, 3, 1, 2, 3. Here's my new G. H is 6, -3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Let me recount that just to make sure. 1, 2, 3, 4, 5, 6. Yep. So 6, -3. That is my H. My new H. My I is now -3, -3. So 1, 2, 3, 1, 2, 3. This is my new I. And my shape should look the exact same, just bigger. And it does. And now, if we wanted to check, we can go graph a line through each of my points. And yes, they would go through the origin. And that means that it is correct. So if I graphed a line through each of my points, this is just to check it. If you had a ruler, this is the best way to do it. But it should go through the origin. Through your 0, 0 point. And it does. So these points are correct. This is the correct answer. That's just a way to check it. So yes, that is a dilation with a scale factor of 3. All right. Now, our last example. This lesson's going pretty good, pretty quick compared to the last. So, through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. What is the scale factor of the dilation? So to do this, we need to know the diameter of the dilation, or that means this new figure that you're looking at. So after the dilation, the new figure was this bigger figure for this one. It's not always going to be the bigger figure, but it's the new one, the last one that you see, over your original. So it'll always, when you're trying to find the factor, it'll always be new over original. So for this one, their new diameter, the new figure that they were looking at was 11.25 because it was after it went through there. This is your original or your actual, like what you're looking at. If we're looking at like a scientific thing, it's your actual size. Your dilation is the one that you see in like a microscope or something like that. So 11.25 was the dilation, and your original was the 0.25 because that's the actual size of a grain of sand. So they did 11.25 divided by 0.25, plug it into a calculator, and they got 45. So the scale factor of a dilation is 45. So new over original. New over original. So that's what we're going to be doing with these. The main thing is to remember new over original and trying to find out which one is the new and which one is the original. So let's try got it. This is our last part of this lesson. So they got it. Lucas wants to enlarge a 3 by 5 inch photo to a 7.5 by 12.5 inch photo. What is the scale factor of the dilation? All right, so try this on your own, and then we'll come back to it. We'll work through it together. All right, so which one is my new? That's what I have to figure out. New over original. So my new one, he's enlarging this photo. My new one would be the one that he enlarged it to. So 7.5 by 12.5 is my new photo. My original photo was this 3 by 5 inches. So I went from 3 by 5 to 7.5 by 12.5. So I'm going to be taking my 7.5 by 12.5 and dividing it by my 3 and 5. So I'm going to actually show you something cool with this. So 7.5 divided by 3. Now, if you have a calculator, I'd use your calculator now because this isn't going to be an even number. So 7.5 divided by 3 is 2.5. Now I'm going to show you something cool. This is really all you needed to do. You didn't have to do both of these divided by each other because 12.5 divided by 5, if you plug that into your calculator, that is also 2.5. You only needed to do it for one of them, as long as it was matched up. So you couldn't do 3 and 12.5 because those aren't in the same order. It has to be the same order. So your first ones, you could do 7.5 divided by 3, or you could do 12.5 divided by 5. As long as you picked like the last ones or the first ones to divide, you only needed to do one because it's always going to be the same. Your scale factor works for both of these. They multiplied 2.5 by both of these to make it the same. So you only have to do it once. So your scale factor for this one is 2.5 inches. Labels are important. And that is this lesson. So hopefully that makes sense. I will post some worksheets. 2 worksheets are going to be your assignment for this one. And we're going to do all of the problems in the one worksheet and 2 of the problems in the other worksheet. And there will be more directions in the instructions for this assignment. So hopefully that'll work. Last time we did a worksheet, it ended up moving some of the stuff when you answered it for a lot of people. So before you exit out after you finish your work, screenshot it and send it to me. Or just screenshot it just in case it moves it, either one. And if it does move it, then you can just send me the screenshot and I can use that. If it doesn't, if you forget or something happens, just send the worksheet to me anyway. I'll figure it out. But try to do the screenshot if you can. It's not too much extra work and it'll help me out a lot. Also, if you just do it, if you have a printer, you print it out, do it by paper in hand. That's perfect. Do that. Send a picture of it to me. That also works. So, starting this week, so Wednesday we obviously have an assessment, but after this week I'll be posting new lessons Mondays and Wednesdays, due the following Wednesdays and the following Mondays. So hopefully that makes sense, and just be looking out for assignments on Mondays and Wednesdays. That's usually when we're going to have to do them. Also, there'll be a review this Tuesday. None of it's mandatory. I will have a review video out too that you can look at and get some practice using that, just to remind you some of the things that might be on the test. I'll go over everything that'll be on the test, and we'll get through it. Hopefully everything's going good. Don't be afraid to contact me, Mrs. Stofflet, and I'll see you for the next video.